Today's lesson combines formulas from both 8.1 and 8.2. We're going to look at calculating or determining area of triangles. Now in geometry, or even prior to that, you likely learned the formula for the area of a right triangle, or any triangle where you can recognize a base and a height. If you have a right angle, meaning a base and a height exist, your area formula is just 1/2 base times height. The base and the height are the lengths that form that 90-degree angle. So we could consider these the base and the height. And you just plug that into your formula. The problem exists when you have an oblique triangle. If you can't draw an altitude in to create that right angle, we can't use the 1/2 base times height formula. Depending on given information, law of sines and law of cosines is helpful for this. Now, if you have printed off notes, go to your 8.1 notes and go to that last example. If you're writing them in your notebook, just continue these notes on from where you left off in 8.2. Here's our first new area formula from lesson 8.1. The area for an oblique triangle. When you're given specific information, you can use a formula with sine. In this area formula, you need two sides, give it a double dash there, and an included angle. So it's a side, angle, side grouping. No matter what combination of two sides and included angle, the formula is kind of similar to the area of a right triangle. We have 1/2 and then we multiply two sides together, similar to a 1/2 base times height. Because we don't have that right angle, however, we're going to do the product of the two sides times the sine value of that included angle. And notice each one of these have that side angle side grouping with them. So you really only need to memorize one formula. You literally just take 1/2 times the two sides times sine of the included angle. Let's try our example. Find the area of a triangular lot containing side lengths that measure 24 and 18 yards with an angle of 80 degrees in between. So if we sketch what this looks like, we're just going to draw an oblique triangle like so. We know one side length is 24, we know one side length is 18, and the angle in between them is 80 degrees. There's your side angle side grouping. Because of this, I'm just going to default that first formula, but you could really pick any one of the three to work with. I'm going to write out my formula K equals 1/2 AB times sine angle C. The two side lengths, A and B, are simply 24 times 18 times sine of our angle, which is 80 degrees. And the great thing about this is we just plug this all into our calculator. Rounding to the nearest tenth, the area for this triangle is approximately 212.7, and our label for area is yards squared. If you're trying to find the area of an oblique triangle and you know two sides and an included angle, apply the formula that uses the sine function. Now go to the last part of the 8.2 notes and we'll look at a different scenario. In lesson 8.2, we have a formula that it doesn't even really include sine or cosine actually. It's called Hurons area formula. Now you're given three sides of a triangle. So if you know all three sides, the area formula is kind of goofy looking. It involves all the sides and then a factor of s, and s is the sum of the three sides divided by 2. So Hurons formula would be best utilized with a side grouping. There's no sine or cosine at all in this formula. And here's our example. Find the area of a triangle with sides 5, 9, and 8 feet. Again, just sketch a triangle, and it's going to be oblique. We don't have any right angles in here that we're aware of. And the sides are 5, 9, and 8. The first thing you want to do is figure out that constant s, because s is in our formula pretty much the whole time. We'll figure out s by taking the sum of the three sides, 5 plus 9 plus 8, and we divide them by 2. 5 plus 9 plus 8 is 22. and 22 divided by 2 is 11. S equals 11. Now to get your area formula, notice we take S minus all three side lengths, and then we multiply it by a factor of S. So our area formula, it's a big square root formula. We all see that. We put 11 on the outside, and then we're going to take 11 minus those three side lengths. We'll do 11 minus 5 times 11 minus 9 times 11 minus 8. So we have 11. 11 minus 5 is 6. 11 minus 9 is 2. And 11 minus 8 is 3. If we multiply all three of these together, 11 times, or four of these actually, 11 times 6 times 2 times 3 is the square root of 396. To the nearest tenth is approximately 19.9, and our label would be feet squared. And there are your two area formulas utilizing sine for one and side length for the other. Both of these formulas will be useful for your worksheet today.